Magis Day, students! Welcome to another day of learning. Today, you will learn to divide a polynomial by a monomial. But before we begin, if you're new to my channel, please do not forget to subscribe and turn on the notification bell after watching this video for you to be notified with my latest uploads. Also, if this video is helpful, kindly give it a like. Thank you. Now, recall that when you were in grade school, you were taught how to add two fractions with a common denominator, meaning to say the denominators are equal. Say, for example, you have a over c plus b over c. Let's go to the direct example. You have 2 plus 5, this one. I'm referring to this one at the bottom. Okay, so you have 2 plus 5 over 3. Okay, remember that this one actually means 2/3 plus 5/3. So we have here a common denominator 3. So in this case, no, notice that in this case the common denominator is 3 and the numerators are 2 and 5. To simplify this, we write the numerators together. So it's going to be 2 plus 5 on top and the common denominator 3 at the bottom. Okay, and take note, class, that in doing this, your denominator must not be equal to 0. For what reason? Because it's going to be undefined. No, your quotient is going to be undefined or math error. No. Now, the same concept actually applies in dealing with division of polynomials. So I want you to look at this example now. Okay, this one. All right. So you have there x plus 3z over 2y. Now take note, class, that x plus 3z, these are the numerators. Okay? These are the terms in the numerator. And then we have here 2y, which is the monomial. So how do we divide the numerator? How do we divide the x plus 3z with the 2y in the denominator? So all we need to do is to divide each term of the polynomial or the binomial with the term in the denominator. Okay, so it's going to be x divided by 2y and then 3z divided by 2y. So take note, there's a common denominator 2y. And we just split, no? We just split the x plus 3z into two separate fractions. Okay, so I'll give you more examples on the coming slides. Now, let's have here our first example. 12m to the power of 6 plus 18m to the power of 5 plus 30m to the power of 4 by 6m squared. Now, in this case, class, the first step is to write it as a fraction. So there, our numerator, in the numerator, we have 12m to the power of 6 plus 18m to the power of 5 plus 30m to the power of 4. And in the denominator, we're going to have the 6m squared. Notice that in the numerator, we have three terms. We have the 12m to the power of 6. We also have 18m to the power of 5 and the 30m to the power of 4. Now remember, the next step after this is to divide each term by the denominator 6m squared. So it's going to be like that. Okay, so the number of numerators, the number of fractions that we have here actually depends as to the number of terms we have in the numerator. So since we have three terms, we also have three fractions here for the second step. After this, we apply the quotient rule of exponent. What does the quotient rule say? In dividing variables, no, that are common, we keep the variable and then we subtract the exponents. So in this case, we have here 12 divided by 6. You deal with the coefficients first. It's going to be 2. and then you copy the variable m, you keep the variable m. So 6 minus 2 is 4. And then you deal with the coefficient again. So 18 divided by 6 is 3. M to the power of 5 divided by m to the power of 2. You keep the variable m. 5 minus 2 is 3. And then another, we have here another set of coefficients. So 30 divided by 6, that is 5. And then m to the power of 4 divided by m to the power of 2 is m to the power of 2. Do not forget that the operation that we're talking about here is division. So our final answer for this example is 2m to the power of 4 plus 3m to the power of 3 plus 5m squared. Now let's have our second example. So it's a trinomial divided by a monomial. Now in this case, we don't have to do the first step because it's already done for us. So the next thing that we need to do from here is to divide each terms in the monomial, each terms in the numerator by the denominator. So we have 50m to the power of 4 divided by 10m to the power of 3 minus, a while ago it was plus, but this time it's minus. Why? For what reason? Because the operator here is minus. So we have to follow that one. And the operator here is plus. So we also have to put that one in between these two fractions. Okay. So after that, we have the 30m to the power of 3 divided by the 10m to the power of 3 and the 20m divided by 10m to the power of 3. So again, the number of fractions that we will have for the second step depends as to how many terms are there in the numerator. So we're done with the second step. We now proceed with the third step. And what is that? Applying quotient rule. So we deal with the coefficients first. 50 divided by 10, that is 5. M to the power of 4 divided by m to the power of 3. We keep the variable m and we subtract the exponents. 4 minus 3, that will give us 1. And then we copy minus 30 divided by 10 is 3. M to the power of 3 divided by m to the power of 3. So that's basically dividing a number by itself. So it's going to be 1. So 3 times 1 is just 3. And then plus 20m divided by 10m to the power of 3. Now notice that for the last fraction class, the exponent of the variable is 1. And in the denominator, the exponent of the variable m is 3. That's greater than 1. So what do we have to do? So what is 1 minus 3? So this one is going to be 1 minus 3. So that is actually equal to negative 2. So that's why at the bottom you have there negative 2 here. Okay? But we don't allow negative exponents. So what do we have to do to make the negative exponent a positive? So this is where the negative exponent rule applies. Okay, this is where we apply the negative exponent. So what will happen? No, we get the base of this exponent negative 2, and that is m. And what is the reciprocal of m? So that's going to be 1 over m. Okay, so it's going to be 1 over m, but this time we have to use the positive exponent. So we have 1 over m to the power of 2. So that's why we have here our final answer, 5m minus 3 plus 2 in the numerator over m to the power of 2. Okay, so that's it. Now let's proceed with. Now we have our third example, but allow me not to read it because it takes time reading all the terms in this example. So I want you to go straight to the solution. Notice that again we have 3 terms in the numerator, so we we proceed with the next step, and that is dividing each term in the numerator with the denominator. So now we have the negative 12p to the power of 5 divided by negative 3p to the power of 3 plus negative 8p to the power of 4 divided by negative 3p to the power of 3 plus negative 6p to the power of 3 divided by negative 3p to the power of 3. Okay, so we deal with the coefficients. What is negative 12 divided by negative 3? That is 4. No? Negative divided by another negative number, that's positive. So we have here positive 4. And then p to the power of 5 divided by p to the power of 3. Applying quotient rule, we have a common variable p, so we keep the p and then subtract the exponents. 5 minus 3, that's 2. And then we have here negative 8 divided by negative 3. What is negative 8 divided by another negative numbers? It's going to be positive. So that's why you have now plus here. So 8 divided by 3, that is that can be simplified. So you just have to write 8 over 3, and then for the variable p, we keep p. 4 minus 3 is 1. So remember, there is an imaginary 1 exponent here. And then negative 6 divided by negative 3, that's positive 2. P to the power of 3 divided by p to the power of 3. So this is basically dividing a number by itself. So it's going to be 1. So 2 times 1 is just equal to 2. So our final answer is 4p squared plus 8p over 3 plus 2. Okay, so it's normal to have a fraction on as the first term, second term, or in the third term. For what reason? For as long as it can't be simplified, there's nothing that you can do. So yes, it's possible. Okay, now let's have our last example for dividing a polynomial by a monomial. So again, we have here a trinomial divided by a monomial. So we write, we have here 3 fractions because there are 3 terms in the numerator. So we divide each term in the numerator with the denominator. But this time, we don't just have one variable, but we have x and y. So again, we deal with the coefficients. What is 45 divided by 15? That is 3. And then x to the power of 4 divided by x to the power of 2. We keep the variable x. We subtract the exponent. So we have to the power of 2 for x. And then y to the power of 3 divided by y. We keep the variable again. 3 minus, so there is an imaginary 1 here. So that's going to be 2. And then 30 divided by 15, that is 2. We keep the variable x since we have here common variable x and y. You subtract the exponents. 3 minus 2, there's an imaginary 1 here. Same goes with y, imaginary 1 as well, because 2 minus 1 is 1. Okay. Now, yes, we have here plus as the operator in between these two fractions. But remember that the plus is being multiplied to a negative fraction. So positive times negative, that's going to be negative. Okay, so there's no need to write the positive anymore because this one is a negative. Negative 60 divided by positive 15, that's negative 4. X to the power of 2 divided by x to the power of 2 is just 1, so there's no need to write it. And same goes with y divided by y, so that's 1. So for the last term, we only have negative 4. And our final answer is going to be 3x to the power of 2y squared plus 2xy minus 4. So that ends my discussion on dividing a polynomial by a monomial. Thank you so much, everyone, for listening, and may God bless you always.